Hello, my lovely students. Welcome to today's session. This is Ms. Ruchika welcoming you to the session today. And this session is going to be mainly on the topic of division of polynomials. So let me introduce you some terms. There are four terms which are very important when we speak about division, and these are number one, dividend, number two, divisor, number three, quotient, and number four, remainder. So one by one, I'm going to explain this to you. So because we are talking about division of polynomials, so we will have a big polynomial having more degree, which we are dividing with a smaller polynomial of less degree. So the one which is having more degree, that is usually the dividend polynomial, which we are dividing. So x square plus 5x minus 4 is an example of a polynomial which we are dividing with the smaller, less degree polynomial x plus 2. So x plus 2 here is a binomial, and that is the divisor polynomial which is dividing the big polynomial. So when you do the division, what you get usually is the quotient and the remainder. So quotient is going to be 1 degree less than the dividend. So it is dividend here is degree 2. So the quotient is degree 1. So x plus 3 is the quotient in this example that you get after dividing these two polynomials. And then when you divide, you have a remainder which is non-zero, negative 10. So this is the remainder, and then we divide it by the same divisor, x plus 2. So this whole division is valid when your x is not equal to negative 2, so that this division is well defined and the denominator is not 0. Now in the session today, we are going to be working on method 1 to divide, that is long division, and the next video for you will be on synthetic division. So these are usually the two methods that we use for division of polynomials. So let's get started with the first method, long division. Okay, so usually long division is the most common type of division method that we use for dividing two polynomials, and this method helps you to find the factors of polynomial as well. So when you do the long division, usually we use this method to either divide the polynomials or hence after dividing to also find its factors. Now, this is the most common method of division. It's a little long, as the name suggests, long division. So you are going to be taking a little more time if you compare it with synthetic division. But the good part of this division method is that it works for any and all kinds of divisors. So for example, let me show you the first one. Here the dividend is a big one with degree 3. The divisor is the small one, which is a binomial x minus 3. The second example here is a big polynomial with degree 4, and the divisor is the quadratic polynomial with degree 2. So whether it is quadratic, whether it is linear polynomial, whether it is binomial, trinomial, any kind of divisor, you can easily divide using this method. That's why it's most common and most preferred method. So on the screen, I have four questions for you. Out of these, I will be working on for two questions for you, and then remaining questions you can try on your own. So let's start with these questions, and one by one, I'm going to be explaining you now how to use and apply the long division method. Okay, so let's start with this method. Step one is to definitely identify the dividend and the divisor. So this is very evident here that the big one is the dividend. This is the polynomial that we are dividing, and the one which is dividing it is divisor, which is a binomial here, only two terms. So step one, you put them in the long division format. So inside comes your dividend, which you are dividing. So I'm writing it here, and make sure it is in standard form, that is the decreasing power. Here in this question it's already in standard form, so I'm not changing anything, but in case it is not in the descending powers of the variable, you have to arrange it in that manner. Okay, so divisor comes outside. So this is step one. Now let's do the division. So in order to find the division, what we need is the question. So we can put the question here, and let's see what the question comes out for this question. So what should be multiplied to x to get the first term? Let's do it term wise. 5x to the power 4. So that means we definitely need 5. That should be multiplied with x, and then x to the power 1 is there. We need x to the power 4. So we are going to multiply with q. So let's do the multiplication. 5x cubed with x will give you the same term, whereas 5x cubed multiplied with negative 4 will give you negative 20x cubed. So I'm lighting the like terms below one another. Now comes the next step where we are going to subtract them. So let's subtract. So we change the sign. I'm putting the new signs in the circle so that you can easily cancel out. Now this is plus 20 minus 3, so 17x cubed. Carry forward the next term, and now let's see what division we need to do. So we already have x, we need 17x cubed, so the next term will be 17x squared. So the same term you get, and this 17x square will also be multiplied with negative 4. So it is going to be giving you 17 times 4 with x to the power 2. So you write that term below the like term. So let's do. So 17 times 4 is 68. So it's a negative sign here. So negative will come. Don't do a sign mistake. Negative 68 x square. Okay, now we do the same thing. We subtract, change sign. This is gone. And this becomes positive. So 68 plus 6 is going to give you 74. 74x squared. Next term is negative x. So definitely this is pretty easy. You will have plus 74. So when you do that, 74x square, and then you have 74 multiplied with 4. So that is 296 with a negative sign. So negative 296. Okay, again you do the same process. So I'm subtracting, this is gone. Now I have less space here. So because it has become plus, I'm going to just write it separately. And we missed out one x here, so we are going to put x as well. So it is 296 minus 1. So in the last step, we have 295x, and then you have the carried plus 12. So this is left. Now it's quite evident we are going to multiply with 295 last term. So this gives you 295x times 4, which is negative 1180. Now you do the same thing, you subtract, cancel the common term, and you are left with 1180 plus 12. The remainder here has come out to be 1192. So this is the end of the division. We have got the remainder which has degree less than the divisor. So we stop the division. So finally your question came out to be, let's write the final thing, 5x cubed plus 17x square plus 74x plus 295. This came as the question, and remainder is non-zero, 1192. So that was the complete division. Okay, so let's summarize the final answer of question 1 now. So this was given to you as the dividend. This was the divisor. And when you perform the long division, you got the quotient as 5x cubed plus 17x squared plus 74x plus 295, as we saw on the last slide, and the remainder came out to be this. So in order to give the final answer, now we will write this using the division algorithm that I explained to you in the beginning of the session. So let me just highlight. So you write your dividend divided by divisor as equal to quotient plus remainder. In this case, the remainder is non-zero, so we are going to divide that by the divisor again. So this is the right side. Now that I'm showing you final answer, this is the quotient as you see, and the remainder divided by the divisor. So this step is giving you the final solution. I hope you've understood very well with all the detailed step how to do the long division. We are going to take one more question in this video. Okay, so let's do the next question, and this one is going to be a little longer. As you can see, your dividend has 1, 2, 3, 4, 5 terms and degree 4, and your divisor here this time is a quadratic of degree 2. So any kind of divisor or dividend you have, you can easily use this long division method. So let's write inside the dividend 4x4 minus 14x cubed minus 12x square plus 110x minus 84. Now, as the name suggests, it's a little long method, so I will use smaller font so that I can cover up the entire part here. So let's solve now. 4x to the power 4, that's what we need, and we have 2x to the power 2. So we are going to multiply with 2x to the power 2. So 2x to the power 2 multiplied with 2x to the power 2 will give you the first term, 4x to the power 4. And along with that, this time we have two more terms. So 2x square multiplied with x will give you 2x cube. Okay, and last term, negative 12 multiplied with 2, that is negative 24x square. So there are three terms that we are getting here. Let's subtract them. So I change the sign and cancel the common terms. So negative and negative will give you negative. Okay, and this will add up to give you negative 16x cube. Don't make any sign mistake. There is plus 24 minus 12, so 12 square is what you get. Okay, so these are the two terms. Let's copy the third term from here, plus 110x. Okay, now you have 2x square and you need 16x cube with a negative sign. So the next term will have negative 8x, right? Because when you multiply 2x square with negative 8x, what you get is negative 16x cube. That's what we want. Okay, now let's do the next term. Negative 8x multiplied with x is negative 8x square, and then this negative 8 will be multiplied to negative 12 also. The negative and negative sign are going to cancel, so you can make it positive 96x. Okay, now we change the sign and negative becomes positive, negative becomes positive, and positive becomes negative. The new signs are in the circle, so let's cancel. So both are positive, so 20x square. Here it is 110 with a positive sign and 96 with a negative sign. So we will subtract them to get 14x. Last term we are now going to copy down negative 84. So quite easy. From 2x square, how will you get 20x square? Just multiply with 10. Okay, so that gives you 20x square. Next term, 10 multiplied with x plus 10x, and next term negative 12 multiplied with x, negative 120. Let's subtract. It's going to be the last step. Sign changes, this cancels, sign changes, 14 minus 10 is 4x. This also becomes positive, so 120 is subtracted with 84 to give you 36. So plus 30. Now the degree has become less. The degree of the remainder is less than the degree of the divisor. So we stop the division. So we have got the two things. We have got our questioned, this one, and we have got our non-zero remainder. So let's now just put the final answer using division algorithm. Okay, so let's do the final answer now. So we divided the dividend with the divisor, and the question that we got was 2x square minus 8x plus 10, as we saw in the last slide, and the remainder that was left with you was 4x plus 36. Okay, now let's use the division algorithm to give the final answer. So division algorithm says that when you are dividing your dividend, this is your dividend, the big one, with your divisor, the small one, what you get is equal to the quotient plus a remainder over your divisor. So what is your quotient? 2x square minus 8x plus 10. What is your remainder? 4x plus 36. And what was your divisor? 2x square plus x minus 12. This is going to be the final answer. We have done two nice long questions on division by long division method. I hope division of polynomials by this method is understood to all of you. Okay, let's see another one last question for today. This is on dividing polynomials with the remainders. Okay, so sometimes your question comes in your exam in this format. So don't get confused looking at this format. It is same as solving with long division. So if you read the question carefully, one ax polynomial is given, one bx polynomial is given. Now first look which is dividend, which is divisor. Definitely this is degree 3 and degree 2. So this is going to be the dividend which you will divide, and this is the divisor which is going to divide. Okay, now if you look at this expression, I hope you can understand this is nothing but your division algorithm. So what the question is asking, let's understand. When dividing a by b, we can find a unique questioned polynomial, that is your qx, and your remainder polynomial, which is rx, which satisfy this given equation. So this is actually your division algorithm, where the degree of rx is less than the degree of bx. That's very important, and that is when we stop the division. So the question is asking you two things. Number one, the questioned qx polynomial, what it is, and number two, the remainder polynomial Rx. So definitely this is a question on long division. So now you know this method. This is another way in which the question can be asked. But as we have learned in the last two questions, the method to solve is same. So let's do long division now for this question. Okay, so I hope you all tried the question. I'm now showing you the solution. I've already solved it here for you using long division. So you know the dividend, you know the divisor. Inside you are going to put the dividend, outside will be the divisor. So when you do the long division method, you get your questioned polynomial qx as 3x minus 4 and your remainder, which is non-zero in this case, as negative 5x plus 8. So finally, as we have learned in the previous slides, you will give your final solution using the division algorithm ax over bx equal to qx plus rx over bx. So just a different way of writing, but your answer is same. So when you divide this dividend 3x cubed minus 4x square plus x with x square plus 2, the divisor, what you get is your question polynomial 3x minus 4 plus negative 5x plus 8, which was the remainder, divided by the divisor x square plus 2. So this is the last question for today. I hope with these three different kind of questions you have now become confident in the method of long division. So before we close this video, this is the last question, last slide for today. I want you to try yourself and practice these two questions, and you can put it in the comment section, your answers. I will check for you, and I hope this video helped you for better understanding for long division method. Until then, this is Ms. Ruchika signing off from the session today. See you in the next video on synthetic division. Bye students.